Hello viewers, let me tell you that this video is a must watch for the students of class 7, 8 and 9. And the topic which I have chosen for you is exponents. And before we all get into the topic, let me motivate you. And for this, I would like to share a small incident that took place in the life of the great Indian mathematician Srinivas Ramanujan. And I hope you all know who is Srinivas Ramanujan. He's a great Indian mathematician on whose birthday we celebrate the National Mathematics Day of India. And so the incident is something like this, that once Ramanujan was ill, and then his professor G.S. Hardy, he went to meet him, and he went through a taxi cab, and the number which the cab had was 1729. And it seemed for Hardy a very dull number. Then he shared with Ramanujan that today is a very unlucky day for me, as I have come here in a very I have come here in a taxi cab which was having a very dull number. Then Ramanujan asked him, "Sir, please tell me what was the number." Then Hardy said, "It is 1729." And then Ramanujan's face light up with a smile, and he said, "Sir, no, it's really a very interesting number. It's not a dull number." So then Hardy asked him that how you can say that this is an interesting number. Then Ramanujan said that it is the smallest number that can be expressed as the sum of two cubes. That is, that too in a two different ways. So then he took a paper and he wrote that 1729 is equal to 10 cube plus 9 cube, and also he wrote that 12 cube plus 1 cube. So these two numbers he wrote. So seriously, it's a very shocking one for Hardy. And even if we think that if we were in the place of Hardy, then we also must have been in a shock, because really, if someone can think in seconds, means it's very unusual. That's like something very unusual actually. So Ramanujan used to do calculations in his minds, and people say that the natural numbers are his friends actually. So this is completely different with many other mathematicians. He was a very unique. Even Hardy compared him with one of the great mathematician Euler. So hope you all enjoyed this. So after this we can start the topic. So let's get into the topic and see what is exponents. So I'll start with basic multiplication. That is, if I take 2 times 2 times 2, so we can write this in some special form, which is, we say that, exponential form. That is, we can write here 2 to the power 3. Similarly, if I take 2 into 2 into 2, and then keep on multiplying this, and this I am doing n times. Okay, like this was 3 times, so now I am taking n times, so I can write 2 to the power n. Okay, so again, if we have 2 times and 3 times, okay, so we can write this as 2 to the power 2 and 3 to the power 3. Got it? So these are how we can write in exponential form. So now let us evaluate few things, like if someone is asking find the value of 2 to the power 6. So how we can solve this? We take this 2 into 2 into 2, we multiply 2 6 times, and we just do normal multiplication, that is 2 to the 4 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. So finally we have the answer. We have the value of this exponential form, that is 64. Similarly, if we have few more problems like 2 by 3 whole power 5. So we can take 2 5 times, and we can take 3 5 times, and we get this as 32 and this as 243. Okay, 240. So now if we have one more question like 2 to the minus 2 to the power 5, then we have minus 2 minus 2 minus 2. We can write it 5 times, or if you know that this identity, that minus times some x, and if x is even, then we have this minus absorbed, means we get only plus out of it, because see, minus into minus, this is 2 times, 2 is even, so we get plus. Similarly, if this minus 1, or you can write only minus to the power some y, and if this y is odd, then we have minus. Got it? So here you see uh, our question contains minus, and the power is also odd for us. Okay, so that means minus will remain here, and if we multiply 2 5 times, and we get 32. So this is simple if you go through these two properties. Okay, so I hope you all know that multiplication of signs. So let me give this for you, that is plus into plus we have plus, minus into minus we have minus, sorry, again plus, and then plus into minus we have minus, minus into plus we have minus. So keep this in your mind, because these are very important when you do algebra. So with this, next I'll move to one more kind of problem which exponents has, that identify which is greater. Okay, identify which is greater. So now which is greater among 3 to the power 4 and 4 to the power 3. So which is greater among these two questions? So directly we cannot say, but we can say it by expanding into normal multiplication and see what the result is. So 3 to the power 4 means I'll write 3 4 times and multiply. So that is 3 3s are 9 and 3 3s are 9, we get 81. Okay, answer for this is 81. Now let us see what this is. 4 into 4 into 4, because 4 cube is there, so I wrote it 3 times, and then if you multiply you get 64. So now everything is clear to you that which number is actually greater. You can see that this is 81 and this is 64. Okay, so we can say that 3 to the power 4 is actually greater than 4 to the power 3. So this is one kind of problem which usually comes in exams and all. Okay, even the topic which I have chosen is a good one for competitive students, those who are giving group D exams, railway exams and all, banking exam. These questions actually uh, comes in those exams as well. So those students are also uh, can go through these topics. Okay, so now a few more questions I'll take so that things will be clear to you. So I'll write one more question, that is if I take find x, so we have the question is 7 to the power x equal to 343. Okay, so we need to find this x here. So the right hand side, if you can notice, that is 314. You take this 314 and find out the factors of 314. So 7 4s are 28 and 7 9s are 63. Again 7 7s are 49 and 7 1s are 7. So we have 3 7s over here. So we write 3 to the power x is equal to 7 to the power x. Sorry, 7 to the power 3. Just now we got. So we can write here x equal to 3. Okay, you can see that the bases are same, so the powers become equal. So we'll see this property after a few minutes, just after explaining few small sums, then I'll go to the properties. Okay, so I'll take one more finding x question. Okay, so 2 to the power 5 is equal to, sorry, 2 by 5 whole power x is equal to 32 by 3125. So this is one more question. Okay, so we need to do the same thing, that is we can find LCM of 32, means we can find factors of 32. So 32, if you take 2 16s are, 2 8s are, 2 4s are, and 2 2s are, and 2 1s are. Similarly, you can take 3125, which goes with 5 actually, and even no, only 5 actually. It will not go with 3 because 3 plus 1 plus 2 plus 5, it doesn't give us multiple of 3. So it's only going with 5. Okay. So 5 6 is 30 and 5 2 is 10 and 5 5 is 25. Again 5 1 is 5, 5 2 is 10 and 5 5 is 25. Again 5 2s are 10 and 5 5s. Again 5 5s are and 5 1s. So finally we have 2 by 5 whole power x, and this is equal to 32 by okay. Instead of 32, now we'll write 2 to the power 5, because we got, see, we got 5 2's here. Similarly, denominator we write 5 5's. Okay, so we can write this as 2 by 5 whole to the power 5, and this is 2 by 5 whole power x, and therefore we can say x is equal to 5 because the base is same. Okay, so we have this. Okay, now we'll go to some special laws involved in this exponent chapter, because the questions which I have chosen till now are very basic questions. Okay, so but if the powers remain very complex, then what to do? Then we should have some set of axioms or some properties or some laws which can help us to solve further. So there are few laws in this chapter, so let me write this: laws of exponents. Okay, laws of exponents. So if I write 5 to the power 3, okay, so we say that this is actually base and the power is actually the exponent. Got it? So with this we can start the laws. The first law is a to the power m into a to the power n. If you notice, the base is same. Okay, the base, the down number, the base is same and the powers are different, and the sign in between is multiplication, and the law says that the power will be added. Okay, next, if you want, I'll give you one example for this. If I take 2 to the power 3 multiplied by 2 to the power 4, so we write 2 and we add the powers. Okay, we add the powers. We get 2 to the power 7. It's very simple, okay? Then the second property is a to the power m divided by a to the power n. Again the base is same, powers are different, and this time the sign in between is division sign. So we take minus in between. Got it? So like if I write x cube by x square, okay, we write 3 minus 2. Got it? In this way, m minus n, that is m is 3 here and n is 2 here, so we write 3 minus 2. So we get x to the power 1. So this is the answer for this specific problem. We can use this property to say something. Okay. Next is, if I take one more property, that is property 3, that any number to the power 0 is equal to 1. Like if I have 7 to the power 0, that means it will give us 1. 100 to the power 0, it is equal to 1. 1000 to the power 0, again it is 1. Okay, any number to the power 0 will give you 1. Then property 4, we have a to the power m, and again take b to the power n. So we can write here ab whole power n. This is for multiplication. Similarly, you can take a to the power m divided by b to the power m. So we can take a to the power a by b to the power n. This is fifth property. Next, one of the important property, any number to the power negative sign, we can write it in reciprocal, then the power becomes positive. Okay, like if I have 2 to the power minus x, so I can write like 1 by 2 to the power x. If I write in 1 by form, that is reciprocal form, then the negative sign goes away. Got it? This is again a very important property which we are going to use many times in the context of this exercise. Got it? Next we take any number to the power m, and if this is equal to any number b to the power m, okay, I'm writing if we have a to the power m is equal to b to the power m, this will imply as base are equal. Okay, if the powers are equal, then the base must be equal. Okay, similar kind of argument is a to the power m is equal to a to the power n. Now you see that the base is same, then the powers must be equal. If there is equal to in between, that means because of the powers are also equal. Okay, this property we have used in this problem. Let me show you this one. So we have used this axiom here, that is 7 to the power x is equal to 343, and we have found that 343 is actually 7. When we have 3 sevens, then it is 343, that is 7 to the power 3. Now by that axiom we can remove the base and we can write that powers are equal. So this is how we got x equal to 3. Okay, so I'll show some more laws and then we'll stop here, because we'll see the remaining sums in the next video. So let us see all the remaining laws, what are there. So next is any number, okay, any number to the power square root. Okay, and the square root means the power is 1 by 2. Got it? So similarly, if I take as cube root of a, then I can write power 1 by 2. So the axioms which I am showing now is for class 9. Okay, class 9 students. You can notice this, and all the previous exams are as well there, but these two are there in class 9, not in class 8 or not in class 7. So the next one is, if I take nth root instead of taking square, cube and something else, so I'll take n nth root we call this. So this is a to the power 1 by n. So again, if we have nth root and inside it is 3 to the power a to the power m, then we write a to the power m by n. Okay, this is power. And one more, that is, if I take a to the power m and there is a bracket and then whole power m, then we have a to the power m into n. Similarly, one more, it is a by b. If I write some m and then if I keep again a bracket and write n, then I can write a by b whole power m into n. So these were the exams. Okay, and we'll see few more problems based on these exams in the next video. Thank you for watching, and subscribe to the channel, and please share as much as possible, because a lot of students are there are facing confusion with this topic. So I hope you all will like it and study well after this. Thank you.